welcome to SGN Tech Forum. Today in this IoT series of video, we are going to explore another sensor, very important sensor, which is called MPU6050. What is MPU6050? It is a 6-axis accelerometer and gyration, right? So first let's understand what is acceleration. From the dictionary, it is increasing in the rate or speed of something, right? That's acceleration, right? Like in car. Gyration, it's a rapid movement in a circle or spiral, right? It's a whirling motion, like your washing machine. So why do we need accelerometer and gyration? What is the application, right? So there are certain application, industry application. It's like if you are capturing a still image or a video, blur free, basically. That's what you can do with that. Then you have wearables, your smartwatches, remote control, motion-based game controllers, right? Even in toys. So that these are the few applications. So let's look at the MPU6050 very closely. I'll show you the chip as well, but before that you can see a clear image on this website, Component 101. As you can see, there are 8 pins, pin number 1 to 8, and each has marking here or label here. So VCC, which is a positive 3 volt or 5 volt, generally we are going to use 5 volt for this. And then ground, obviously. SCL and SDA, one for clocking, one for data, and we will see why these pins are used, right? And then we have XDA, XCL, and ADO and interrupt. They are a few optional pin, right? So let's understand the pin out configuration. Pin number 1, VCC, 5 volt, right? Second is ground. Third is use SCL, which is used to provide clock pulse for I2C communication, right? And this is pin number 4 is SDA, used for transferring data through I2C communication. All right, so we'll see what is I2C communication in another link, but as you can see, the main component is SCL and SDA, right? These are the pins we are going to use. SDA for our data capturing, acceleration and gyration, and then we have clocking for accuracy. All right, what is MPU6050? It is Micro Electro-Mechanical element, like sensor, right? It's a 3-axis accelerometer and 3-axis gyrometer. Okay, so before we start taking deep dive into the chip itself, let's understand what is I2C. All right, so this is the documentation from MathWork. As you can see, Raspberry Pi I2C interface. This is how it looks like. Inter-integrated circuit, I2C, is a protocol for communication with low-speed peripherals, right? So in a lot of other technology where the data rate is very low, we are going to use I2C pins. Unlike typical LAN networking where you're using Ethernet and other things, right? This is I2C serial communication. Depending on the model and revision of your board, which is like Pi 2, 3, or 4, Pi hardware has 1 or 2 I2C buses. Each bus has I2C central connected to 2 bidirectional lines. So basically they are bidirectional lines. One is SDA and one is SCL. These 2 lines are connected to a pair of pins such as I2C is SDA, and this is the board BCM pin number GPIO2 and GPIO3. So your GPIO2 is SDA and GPIO3 is SCL. All right. You can connect multiple for your analog ADC converter and all those things. So you can use your I2C pin for that. Raspberry Pi hardware support only 7-bit addresses and 7-bit address space, 192 unique address space. So each I2C has their unique address space, and that we will see when we connect our chip to the Pi. All right. So what you can see on this website, Component 101, similar thing you can see here on the pin itself, chip itself, right? So this chip is totally marked starting from VCC all the way to interrupt, right? And a few more things to note about this. When you look at the data sheet, because we now know about the pin, but what other component we have here, right? So this is, you can see, product overview 50. So we have ADCs, okay, and then it has a DMP, inbuilt DMP, and it is all specifications. So I'll totally encourage you to download this data sheet and give it a read. Okay, so DMP is there for processing, right, on the chip itself. Okay, so this is kind of like very easy to get started with. All right, so please do read the data sheet. And now what we will do, we'll go ahead and connect the chip to the breadboard and run our program, right? So this is again pinout XYZ, and here, as you can see, GPIO2 is SDA, GPIO3 is SCL, and if you want to find more about that, you can actually click on this. So this layout is clickable, and you can see what it does, and everything is listed here, right, for SCL and SDA. So as you can see on my GPIO pinout, I have kept the wire connection ready. Okay, so let's look at this. Pin number 3, which is SDA in yellow. Pin number 5, which is SCL in orange. Then I have VCC white and a ground gray. All right, so let's fit in this MPU6050 on our breadboard. And as you can see, my Raspberry Pi is not powered up. So the best practice is never connect your sensors or actuator while keeping your Pi powered up. Okay, so first make the connection and then power it up. All right, so let's connect pin to pin. So the first one is VCC, and that is a white pin here. Okay. The second one is ground, which is gray pin. It goes here. Then we have SCL, and SCL, as you can see, it is pin number 5. Pin number 5. Pin number 5 is SCL. Yes. So this is my pin number 5, orange. That goes here. And then we have SDA. All right, so SCL and then SDA. That's how it is marked. Okay. Let's look at the component 101 just to verify one more time. So we have SCL and then SDA. And SDA is pin number pin number 3, SDA. All right, connection looks good. It's always a good practice to verify things. All right, now what I'm going to do, I'm going to power up my Pi. Okay. So for that, I'm going to power it up. It is powered on. You can see since we have connected VCC and ground, MPU has light is up. Okay, but there is no guarantee that it's working. I mean, until you run the program. Okay, so now what we are going to do, next is log into. All right, so here we are logged into our Pi, and now what we are going to do, we are going to configure or look through the program. So let me go to the program, and before we do that, let's verify if MPU6050 is detected. So for that, what you have to do, you have to just enable your I2C. And how you can enable your I2C, let me show you. Either you can do sudo raspi config and then go to interface option and enable I2C, or what you can do, you can simply say sudo apt get install I2C tools. So this is already installed, and let's say verify if we have I2C detected or no for its hardware address. As you can see, it is detected as an address 68. All right. So now we have a program already written. It's a sample program available on internet. I'll post it in my GitHub link as well. Okay, I cannot type very well. I'm loose here. All right, so let's look at the program, MPU program. So basically what we are doing, we are calling some functions, and these functions are nothing but they read raw data from accelerometer and gyroscope for 16-bit values, since only 16-bit is supported, up to 65536, and then return the value. As you can see, 3 axes for accelerometer, 3 axes for gyrometer, and then some math work here, and you will see your data printed. So if you look closely on the chip itself, you will see that there is some sign which is denoted as x-axis and y-axis for acceleration and gyroscope, even z-axis, right? So the way you move, you are influencing the data. So let's run this program. All right, as you can see, I am getting data here, and if I start moving this, you can see. See, speed is getting up because it's moving in x-axis. If I move it in a circular motion, you can see gyroscope reading is changing, right? So you can use it no matter in whatever fashion, circular motion, linear motion, for speed and everything, right? And all this data is printed with respect to that. All right, so I'm influencing, like fluctuating very high like this, and you can see the data is getting generated. Now let me put it back, and it should stabilize to some lower value because there is no gyration, no acceleration here. All right, so this is what I wanted to show, and knowing your sensors and actuators are very important in IoT, because if you know your hardware or MSME, then only you can write a efficient program and come up with innovative use cases. So thank you for watching. I'll see you in another video. And if you like my IoT series of video, please like and subscribe, and send me a comment what you would like to see in next videos. Thank you very much.